as challenging, but you get the idea. It's really important. Your heading for today is Right Triangles, Lesson 9.1, and be sure and include today's date so that you have organized notes, okay? Right Triangles, Lesson 9.1, be sure and include today's date. Alright? Okay, here we go. Now, in Chapter 4, we learned different ways to classify triangles by angles. Remember, acute triangles, obtuse triangles, equiangular, etc. One of those ways was a right triangle, okay? Now just sit back and listen, okay? It is impossible for a right triangle to be acute, obtuse, or equilateral. Why? Well, an acute triangle has 3 acute angles, right? Well, a right triangle has 1 right angle, so that takes care of that. An obtuse triangle has 1 angle larger than 90. Well, students, if you have an angle here that's 90, how can one of these angles here be larger than 90? That would give you 2 angles equaling over 180 degrees. And we know that the 3 angles have to add up to 180. So that takes care of that. And we know it can't be equilateral because an equilateral triangle is always also equiangular. And there's no way a right triangle can be equiangular. So if you have a right triangle, rest assured it will never be acute, obtuse, or equilateral, or equiangular for that matter. Okay? Now, even though these next notes I'm about to give you are probably not necessary, I still want to make sure that everyone remembers the parts of a right triangle. So please take time and write these down so there's no confusion. Okay? Here we go. Draw a right triangle in your notes if you would, please. And here we go. Let's label these quickly. This angle here, obviously, is called your right angle. Okay? It's called your right angle, 90 degrees. Alright? Now, the right angle always points to the hypotenuse. Okay? The right angle always points to the hypotenuse. So this side over here is going to be called the hypotenuse. If you want a spelling on that, it's Hypotenuse, okay? Hypotenuse. Now the other 2 sides that are not the hypotenuse are called the legs. So this is a leg, and this is a leg. Remember when we use Pythagorean's theorem, I always taught you guys leg squared plus leg squared equals hypotenuse squared, okay? I never cared for a squared plus b squared equals c squared. I like this a lot better. Now, so that's what we call these 3 sides. The side across from the right angle is called the hypotenuse. The other 2 sides are called the legs. Now this angle here and this angle here, they are the acute angles, and they will always be acute. They will be less than 90. So if you want to make note of that, these 2 angles here are always going to be acute angles. Okay, let me pause a second. I'm going to get a drink. Let you guys finish copying this information down, then we'll move on. Parts of a right triangle. Okay, I'm going to move on. If you need the teacher to pause the video, just let the supervising teacher know. Let's continue on. Now, when it comes to proving 2 right triangles to be similar, let me stop and say it again. I want to make sure I have everyone's attention. When it comes to proving 2, what kind of triangles? Right triangles to be what? Not congruent, but similar. Think about it, students. All that you need to show is that one of the acute angles is congruent to another acute angle in the other triangle. Let me show you what I mean. Okay, look. Here's a right triangle. So if you know one of the acute angles is congruent to one of the acute angles over here, then you automatically have two angles congruent to two angles. So let me go over that again. If I give you a right triangle and you know one of the acute angles is congruent to another acute angle and another right triangle, then you know right away the two triangles are definitely similar because you have angle, angle in one triangle congruent to angle, angle in another triangle, okay? So keep that in mind. We're actually going to talk about that a little later, okay? During a proof. Contain your excitement during a proof that we're going to do later, okay? Now, let's take a look at our first theorem of the video, our first theorem of the day. Take a second and copy this down. We're looking at 3 total theorems today. Theorem 9.1, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to each other, and they're also similar to the original triangle, okay? So I'm going to read that again. You guys can copy this down. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, now you know I'm going to give you a picture of this in just a second, but go ahead and copy this down. Then we're going to talk about this. I want to show this to you. Then we're going to talk about proving this. And I need you to really, really pay attention. Take some really good notes. I love trigonometry. I think you guys are really going to enjoy this. It's really a lot of cool stuff, okay? Give you a couple more seconds to copy this down. Okay, students, here we go. Now, go ahead and copy this in your notes if you would, please, okay? Let's go ahead and draw a triangle like this and like this. And we're going to call this right here our right angle, okay? We're going to call this triangle A, B, C, okay? Now, look what it says. If an altitude is drawn, now, do you remember what an altitude is? Let me refresh your memory, okay? An altitude is drawn from a vertex of a triangle to the other side in such a way that it's perpendicular to the opposite side, okay? So, we're going to draw, let me say it again, it's a line drawn from a vertex to the opposite side in such a way that's perpendicular, okay? So, we're going to draw an altitude to the hypotenuse, so we're going to start here. Remember, this is my right angle, so if I'm going to draw an altitude to the hypotenuse, then I have to start here. So I'm going to draw an altitude, are you ready? Here it is. There we go. Now when I did that, notice there were two triangles formed. Triangle number 1 and triangle number what? 2. Do you see that okay? Alright, okay. Well, that's what it's talking about here when it says, then the two triangles formed are similar to each other, and they're also similar to the original triangle, okay? So, let me show you what's going on here. Come over here and put if, okay? If altitude, oh, we need to put a letter here. Let's call this D, okay? Put D there. If altitude BD is drawn, that's an A right there. I do know how to spell. It's drawn from the right angle. Then, now students, you know when Mr. Earhart says please listen, I don't say that because I feel like I just want you to always listen. I mean, when I say please listen, I'm about ready to say something A, real important, or B, something that's easy to get confused. I don't want you to get confused. So, are you listening? Are you ready? Please listen, okay? I'm going to show you we have triangle number 1 similar to triangle number 2, similar to triangle number 3, and triangle number 3 is this whole big triangle. But here's the catch. You have to be careful how you list them out, okay? Because later on, we're going to solve some problems, and they're not going to be easy. Believe me, they're going to get confusing, because we're going to learn 2 other theorems today that deal with taking square roots of numbers and multiplying numbers and all kinds of stuff, okay? So you really have to know how these similar triangles are drawn, okay? So watch carefully how I do this, okay? Triangle A, B, D, okay, is similar to, now watch carefully. Triangle. Triangle. Well, you know what? Before I write this down, let me show you. So I want to highlight this for you. Don't lose sight here. Triangle ABD is this triangle here. Do you see that okay? Alright. Now the next triangle I'm going to write down is this triangle right here. Okay? Got it? Okay. Now, most of you probably thought it would be ABD, ABD. Okay? And then, because A came first here, you'd put C first over here. And that's wrong. This angle here is congruent to this angle up here. So remember, when you list out your similarity statements, you must match congruent angles with congruent angles. So if A comes first in this triangle right here, then angle B has to come first in this triangle right here. So this angle here is congruent to this angle here. Got it? This angle here is congruent to this angle down here. So watch how I write. I wouldn't put all these marks in your notes. I mean, you can if you want to. I think it'd be confusing. I'm just trying to give you a picture of it. So watch this. Triangle ABD. So A came first. So for me, B would come next. Up here. Okay? Now, next is B. Okay? ABD, which is this angle here. Don't become confused. ABD. Well, that's congruent to C down here. So C comes second. Notice in triangle ABD, D is next. That's a right angle right here. Well, the right angle over here in this triangle is D. So a D goes here. So if you're a little confused, just memorize it, guys. It's triangle ABD, similar to triangle BCD. Remember, this angle here goes with this angle here, and this angle here goes with this angle here. Please don't forget that. Now, don't forget also, I can state that these triangles are similar to the entire big triangle. Okay? So let's keep that in mind. Alright? So, here we go. Notice that I have angle A first. Okay? See that? So I'm going to put A first right here. Then next is angle B. Now remember, angle B in ABD is this angle here. Got it? And remember, this angle here I showed you was congruent to this angle here. Okay? So, if B is next, then C would come next over here. Okay? And then notice your last angle here is D. D is a right angle. So what is your right angle in your big triangle? B. This up here is your right angle. Now look, this is not easy if you're confused. You're very normal, but you might just have to resolve yourself to the fact that you might just have to memorize this, okay? But also, it's my job as a teacher to break this down and show you how these are set up. It's important that you know that. So, if you start solving for parts of these triangles using proportions, you know which sides correspond with which sides in these little triangles, okay? In these triangles, so here's my little triangle. A, B, D. Here's my other little triangle right here. B, D, C. And here's my big triangle right here. And that's A, B, C, okay? So, be really careful here, okay? This angle here, if you want to write it out like this, it might help you. This angle here is congruent to this angle here. This angle here is obviously congruent to this angle here, and this angle here is congruent to this angle over here. Alright, now, this angle here is obviously congruent to this angle here. Okay, this right angle here is congruent to this right angle here. Okay, so the only thing left is this angle here is congruent to this angle here, or this angle here is congruent to this angle here. So please understand this, and please take some really good notes. I'm going to move on, but you need to really study this and be very familiar with this, okay? Now, here comes the really bad news. Having you prove theorem 9.1 on a quiz or a test is definitely reasonable. And I'm not going to do it for you, but I will lay out the thought process, so you better be working on this and thinking this through, okay? I'm going to take this right out of the book and show you exactly how this is done, okay? So I want you to draw another triangle in your notes. looks like this. Okay? And we're going to go ahead and put a right angle in here like this. And we're going to go ahead and drop our altitude down. Okay? There's our altitude. Now please watch carefully what I do. I'm going to call this triangle P, Q, R, S. Got it? Now, I want you to label some numbers, or label some angles with numbers, and please do this very carefully, okay? 3, 2, angle 1 right here, and I'm going to call this angle 4 right over here, right there. Now, please just relax and listen to me. On a quiz, I'm not saying on a quiz or test I would say prove theorem 9-1. That'd be a pretty monster proof because you've got to prove that 3 triangles are similar, to each other. So instead, I could see me giving you a drawing like this in a test or a quiz. I could see me saying to you, prove that triangle PQS is similar to triangle. And I've got to think this through myself. PQS QRS. And so how would you do that? Or I could see me saying to you to prove this triangle here is similar to the big triangle or something like that. So I'm not going to say prove theorem 9-1, but I could give you a problem like this, like that was on your test the other day, and just say prove this. So let me give you some ideas that are really going to help you, okay? Please, please watch carefully. Number 1, write down these hints that would help you, okay? Hint number 1, all 3 triangles have a what angle? A right angle. Now look, stop, listen, think. How many angles do you need in a triangle to be congruent to another triangle to prove that the 2 triangles are similar? 2. Right angle, angle. Well, you've already taken care of 1. Every single one of these triangles has a right angle. So think of this tip right here, guys. This is so cool. We learned many, many, many moons ago that if 2 angles, write this down, if 2 angles are complementary to the same angle, then they're congruent. So you could use that in a proof. That's a theorem. If 2 angles are complementary to the same angle, then the angles are congruent. You could use that in your proof to prove that some of the acute angles are congruent. Watch, let me show you, okay? Now, let me think this through here for a second. Let me look this over. Watch this carefully and see if this makes sense. Take some good notes on this. Look, guys. Angles 2 and 1 are complementary, right? And look at this. Angles 3 and 2 are complementary. Whoa, Mr. Earhart, what are you thinking there? How are they complementary? Guys, we learned a long time ago that 2 acute angles in a right triangle are always complementary. Okay, so here's your right triangle right here. If this is 90, then these 2 add together have to be 90 also. 90 plus 90 is 180. So look, if 2 and 1 are complementary and 3 and 2 are complementary, look, angle 1 is complementary to what angle? 2. Angle 3 is complementary to what angle? 2. So angles 3 and 1 are complementary to the same angles, thus they're congruent. Okay, I'm trying to lay this out for you, okay? Now, look what else I can state, guys. Take a look at this. If I'm going too fast, just have the supervising teacher pause the video. Look at this over here. We just said that angles 2 and 1 are complementary, right? And we know here, look over here, angles 1 and 4 are also what? Complementary right here, because they're the acute angles of this right triangle right here. So, with that in mind, look, 2 is complementary to 1, 4 is complementary to 1, 2 and 4 are both complementary to 1, so 2 and 4 are congruent. That's 2 from this triangle and 4 from this triangle. So I hope you're taking really good notes. And, get together over a weekend and have a geometry proof party. Just kidding. But listen, get together with with some friends and work on this, but you should, again, I'm not going to say prove theorem 9-1, but I'm going to say to you, you should be able to prove that this triangle here, I'll call it triangle 1, is similar to triangle 2. I could give that problem to you and ask you to prove it. So please take all this and use it, alright? Now, moving on. There are two, totally switching gears. So listen carefully. There are two different means in mathematics. Okay? There are two different means. Okay? There is an arithmetic mean. Now that's the one you're used to. Remember, mean means average. Okay? This is the one you're used to. If you had an 80 on a test, a 90 on a test, and a 95 on a test, you would add those three up and divide by what number? Divide by 3. You guys know that, okay? That's the good old-fashioned arithmetic mean, okay? You know how to do that. But there's also something in math called a geometric mean, okay? And that's what we're going to focus on today. So there are two different means in mathematics. One is the arithmetic mean. That's the one you've done since you've been in elementary school. And there's a geometric mean, okay? Now, the arithmetic mean, like I just said, is the one you're used to. The geometric mean, however, is a little different, and it's decently confusing, so take good notes and please pay attention. Instead of trying to give you a word definition, let me just show you what the geometric mean is, okay? So take some really good notes on this. Copy this problem down. I want you to find the geometric mean of 2 and 10. Please copy that down. Find the geometric mean of 2 and 10. Now, if I asked you to find the arithmetic mean, that's easy. You would take 2 plus 10, you would get 12, and you would divide by 2 because there were two numbers, and the arithmetic mean would be 6. That's elementary, easy math, okay? But I'm asking you to find the geometric mean. The geometric mean. Now I'm going to show you two ways to do it. And guess what, students? You need to know both ways. Please believe me, I wouldn't say that if it wasn't true. I would not make you learn extra math just to be mean to you, okay? Well, maybe I would, but besides the point, you're going to need to know both of these methods, okay? So the first way to find the geometric mean of 2 and 10 is to write a ratio with a 2 up here, another ratio with a 10 down here, so they're diagonal, and then you put an equal sign and put an x and an x. That's easy, isn't it? And then solve. So x times x is x squared, 2 times 10 is 20. Now, those of you that have not had Algebra 2 yet, you might be a little rusty on this, but listen to me. If you have an x squared, in order to get rid of the x squared, you take the square root of it. But if you take the square root of one side, you must take the square root of the other side, okay? So there we go. The square root of x squared is x. Excuse me for a second. The square root of 20, we're just going to leave it the square root of 20, okay? And if you type that into your calculator, let's see, you would get 4.5 rounded. Now, you're probably saying, Mr. Arrow, you messed up. You forgot to put plus minus. No, whenever you're dealing with geometric mean, you take the positive number only. So you could say the geometric mean of 2 and 10 is the square root of 20, or 4.5. Okay? Now, Mr. Airy said there's another way to do this. Yes, another way to do it is to skip this step here and simply do this. Multiply the two numbers together and take the square root of it. So anytime I ask you to find the geometric mean of two numbers, you simply multiply the two numbers together and take the square root of them. Well, Mr. Earhart, this is a no-brainer. This is easier. Forget this. Well, you're not going to be saying that once we start getting to some of our problems here in a couple minutes where we're solving for missing parts of right triangles based on a theorem and based on geometric mean. You're going to want to use this method sometimes, and sometimes this method over here, trust me, okay? Because here's why. Sometimes I'm going to give you the geometric mean and leave out one of these numbers. Like I might say the geometric mean is 20, square root of 20, and the other number is 2. Find the other number, okay? And you might say, well, it's easy, but you'll be surprised how it's not as easy as you think, especially, well, I'm going to stop right there, okay? So let's continue on. You might be thinking, where'd that come from out of the blue? Why do we have to learn how to find the geometric mean? Well, in order for you to use the next two theorems, you need to know how to find the geometric mean, excuse me, okay? here we go. Please take some really good notes, okay? Here's our first theorem that deals with the geometric mean. Copy this down. Theorem 9.2. You need to know these, okay? In a right triangle, the length of the altitude drawn from the right angle to the hypotenuse is the geometric mean of the lengths of the two segments of the hypotenuse, okay? Now, I'm not going to read that again. You write that down. I'll wait a minute. Then I'm going to give you a picture of it. Then we're going to talk about it, okay? In a right triangle, the length of the altitude drawn from the right angle. I said I wasn't going to read it again, didn't I? Okay, I'll be quiet. Copy this down, please. Okay, if you're not done copying this down, you can still keep working on that. I'm going to draw a picture for you here, okay? So, here's your right triangle, alright? It's drawn right here. And, hold on 1 second here. We're going to draw this one a little differently than what we have been doing. So, here's your right triangle. Okay, there we go. Beautifully drawn. Now, here's what it says. In a right triangle, the length of the altitude drawn from the right angle to the hypotenuse. So here's my altitude. Are you ready? I'm going to draw it right here. It's got to be perpendicular, so it'll be about right here. There's my altitude. So, okay, there we go. Let's go give this some names. A, B, C, D. Now, the length of the altitude drawn from the right angle to the hypotenuse is the geometric mean of the lengths of the two segments of the hypotenuse, okay? So, for example, see this segment here? Pretend that was a 2. Got it? See this segment here? Pretend that's a 10. In order to find the length of BC, you would find the geometric mean of 2 and 10, which we already did earlier. And what did we get? The square root of 20. Do you see it okay? That's what this theorem is saying. Now, usually I give you a picture, and I come over here and I put if, and then I'm not going to do that in this one. I want to focus on the numbers, okay? You see what I'm saying here? So if an altitude is drawn from the right angle to the hypotenuse, these two segments here that are formed, this segment and this segment, if you'll find the geometric mean of those two numbers, it will give you the length of this altitude every single time. Now, I'd like to show you why that's true. If you'll allow me that, just a second to do that, okay? And no, you don't have to know it, and no, you don't have to take notes, but would you please just give me 60 seconds to explain this? Please watch this, okay? Remember, in our last theorem we learned, whenever a right triangle has an altitude drawn from the right angle to the hypotenuse, we know this triangle here is similar to this triangle here. Guys, we just learned that in theorem 9.1. So watch what I do here. This is so cool. All of math is cool. This is extra cool. Look, if I have triangle A, B, C, it's similar to triangle B, D, C. Okay, we just learned how to do that earlier. Now, we're dealing with side AC right here. Do you see that? So here's AC. See AC over here? I'm going to put AC over what? What side over here corresponds with AC? BC does, okay? So I'm going to put BC, okay? Now what other segment are we dealing with? CD. Well, here's CD right here, okay? What side corresponds with CD? BC. So I'm going to say AC over BC equals BC over what? DC. Dude, look. My brain just blew. Look at this. Remember back here earlier when I told you to find the geometric mean, I said to put a 2, like if we're doing with 2 and 10, you put a 2 there, and a 10 here, and an X here, and an X here, and set them equal. Look, I've got BC here, and BC here. AC's a number like 2, DC's a number like 10. There it is. BC times BC is BC squared. 2 times 10 is 20. Take the square root of both sides, get the square root of 20. Now, some of you might say, Mr. Earhart, I I was lost when you said welcome to class today, and that's fine. You don't have to understand what I just said. I'm just trying to show you why this works. Do you know what you have to know? You have to know that this segment here and this segment here, when you take the geometric mean of them, gives you this altitude's length right here. That's what you need to know, okay? And let's practice, okay? Let's quickly look at two problems that we can solve by using Theorem 9-2, okay? So take some really good notes. You're welcome to work ahead, but like I always say, if you work ahead, you better keep one eye up here and make sure you're doing it correctly, okay? Copy this triangle down just the way it is, please, and then write this down off to the side. Copy this triangle down, please, and then copy this information down over here. Now notice, students, I did make, I guess, one little mistake here. I probably should put a right angle here so you know you have an altitude. So go ahead and put a right angle here and there. Copy this triangle down in these numbers, all right? And let's jump into this right away. Now look, QT equals 5. So I'm going to put a 5. Well, let's stop and look at this first of all. Notice I have a big right triangle in which I've drawn an altitude from the right angle to the other side, okay? So I might be able to use Theorem 9-2. Now, QT is 5. RT is 10. Find the length of TS. Okay, now please don't freak out, just listen. Remember what we just learned. This length right here, 10, is the geometric mean of these two numbers here, correct? So, think about this. Remember what I taught you to do. We're taking the geometric mean of these two numbers. And when I take the geometric mean of these two numbers, they should equal what? 10. So the two numbers that I'm taking the geometric mean of are these two segments here. So I'm going to put my 5 up here and my x up here. Okay? Alright. Bear with me, please. Don't get frustrated. Watch this. Let's go way back here. Right here. Remember when I told you we're going to find the geometric mean of 2 and 10? I put the 2 up here and the 10 down here. Remember that? Okay, same thing. That's what we're doing here. Way too far ahead. I'm taking the geometric mean of these two numbers here, so my 5 goes here, my x goes here. Put an equal sign. Now, my 10 goes here and here. That's the actual geometric mean, okay? So, 5 times x is 5x. 10 times 10 is 100. Set them equal. Divide both sides by 5, and x equals 20. Now, if you don't like using these ratios like this, I understand that. I can handle that, okay? That's fine. Maybe this is easier for you. Anytime you're looking for the geometric mean, you always take the square root of two numbers, right? We'll call it a and b. Alright? So, geometric mean is what? 10, correct? Sure it is. And what two numbers are you dealing with? 5 and x. So the square root of 5x. Some students like to do it this way, and that's fine. You square both sides to get rid of your square root. So you square 10, you get a 100. You square a square root, and you're left with 5x. And if you don't like this way, now divide both sides by 5 and you get 20. If you don't like this method, that's fine. Just remember, the two numbers that you're taking the geometric mean of, one goes here, and the other one goes here. And then the actual geometric mean, which is 10, goes here and here. That will work too. Either one of these two methods will work, okay? Let this sink in. So the answer is 20, okay? And then check your work, guys. Multiply these two numbers together and take the square root of them, and you'll get 10, okay? Let's try another one, alright? Anytime I'm going too fast, just let the supervising teacher know, okay? Alright, next one, here we go. Alright, same triangle, different lengths here. Here we go. QT is 4. TS is 9. Find RT. Well, students, that's simple because, anytime you have an altitude drawn from a right angle to the hypotenuse, this length right here is always going to be the geometric mean of these two numbers here. Got it? So, let's take the geometric mean of 4 and 9. So I put my 4 here and my 9 here. and then the actual geometric mean goes here and here. X times x is x squared. 4 times 9 is 36. Take the square root of both sides. X equals 6. Now, if you like using the other method where we say geometric mean equals the square root of a times b, no problem. Here's the two numbers you're trying to find the geometric mean of. So a is 4 and b is 9. So the geometric mean equals the square root of 4 times 9, which is 36. And the square root of 36 is 6. Either way, you get the right answer. So before I move on, I want to say this one more time. The length of the altitude drawn from the right angle to the hypotenuse is the geometric mean of the lengths of the two segments of the hypotenuse, okay? So this length here will be the geometric mean of these two lengths right here. Alright, let's continue on. Okay, finally our last theorem for the day, okay? So, copy that down please. I will read it one time and then let you guys copy it down. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Each leg of the right triangle is the geometric mean of the hypotenuse, and the segment of the hypotenuse that is adjacent to the leg. Alright, that's a lot. Copy that down, and then I'm going to explain this to you so that you totally understand it, okay? So please don't freak out or worry about it. I will explain this to you, okay? Quickly copy this down, and we will go over this. Okay, I'm going to move on, guys. If you're still copying, that's totally fine. Now, I want to give you two pictures here so that you understand the difference. So please be patient with me and trust your teacher. I know what I'm doing here, okay? Here's one triangle. Here's one right triangle. Okay? And here's the other one right here. Now, please notice the difference. What we just learned a second ago was this. Okay? Forget theorem 9.3 for a second. A second ago we just learned that if I draw this altitude right here, this number here is this length right here. This length right here, students, is the geometric mean of what two numbers? This length here and this length here. Got it? That's what we just learned. Now let's come over here and look at something different, okay? Go ahead and draw your altitude from the right angle. Now listen carefully what it's saying. Each leg of the right triangle is the geometric mean of the hypotenuse, and the segment of the hypotenuse that's adjacent to the leg. Let me show you what that means. Please take some really good notes, okay? In fact, you're going to need two of these triangles, so I'm going to quickly do something here. In your notes, I would encourage you to draw two triangles like this, okay? Now, please watch carefully. Here we go. Now, each leg of the right triangle is the geometric mean. So see this leg right here? This leg right here is the geometric mean of what two numbers? What does it say? Of the hypotenuse and the segment of the hypotenuse that's adjacent to the leg. So this leg right here is the geometric mean of, are you ready? This entire length here. That's one number, isn't it? And this length right here, I'm going to use a different color of ink because I'm so creative. Got it? So, let's pretend this whole length right here was 15 from here to here. And let's pretend this length right here from here to here was, I don't know, 9. This length right here is the geometric mean of 9 and 15. Now take some good notes. You know what kind of notes to take to write down here so you won't forget that, okay? geometric mean, the length of this leg right here, is the geometric mean of this length and the whole hypotenuse. Now I'm going to move on. It's the same thing down here, guys. This leg right here, this bottom leg, and that's why you had you draw two of these triangles. This bottom leg here is the geometric mean of, are you ready? This length here and the entire length of the whole hypotenuse. Okay? So, let's say the entire length of the hypotenuse was 15 from here all the way to here. And let's say this line right here had a length of 6 from here to here. This leg right here is the geometric mean of this little segment and the whole segment here. Now I'm going to pause. You take notes however you need to so that you remember that and so you don't forget this. So this theorem here, 9.2, this is theorem 9.2. Theorem 9.2 helps you find the length of the altitude. Theorem 9.3 helps you find the length of the leg of the triangle and the leg of the triangle, okay? So here we have the altitude related to these two segments. Here we have the legs related to the hypotenuse and part of the hypotenuse. So please take notes on this. I'm going to move on. So in just a second, so have the supervising teacher pause the video if she needs to. And then we'll continue on in just a couple, and then you can restart the video if some of you need more time, okay? So I hope you're getting this. Take really good notes. All of you can do well in this trigonometry chapter. You might have to go home and do a little work out of your own time. And actually, I'm going to be a little sarcastic with you. Forbid that we actually have to work hard. In a Christian school, we should have good academics. So you might have to go home and do a little bit of work on these, okay? Alright, let's finish up with a couple of problems. Copy this down if you would, please. Here's back to our old triangle we had before. Copy this down, and then copy down these lengths. And let's go ahead and see if we can't solve for section QT. As always, you're welcome to work ahead if you want to. And by the way, the video's almost over. One more example after this and we're finished. So, feel free to work ahead, but if you do, keep one eye up here and make sure you're solving these problems correctly. I am going to move a little faster now. We got to wrap this up. So, QR is 12. QS is 20. It's the whole hypotenuse. Find the length of QT. This little length from here to here, we'll call that X, okay? Now look what we have, students. We have a leg in relationship to this segment here and the entire hypotenuse, okay? Now, can we find X? Well, yes, we just learned that this number here, this leg, is the geometric mean, right? It's the geometric mean of these two numbers here. So the two numbers I'm finding the geometric mean of are X and 20. There's my two numbers. And then the actual geometric mean is 12. So we put the 12 here and the 12 here. Here we go. 12 times 12 is 144. 20 times X is 20X. Now we're going to divide both sides by 20. And we're going to get, let's see what we get here. I had this done somewhere already. I believe we get 36 over 5 if we reduce it correctly. 4 goes into this. 3, yes. So divide both sides by 20 and you'll get 144 over 20 equals X. And if you reduce that, you'll get 36 over 5. So there's the length of X. Now I don't care if you write your answer 36 over 5. You're welcome to write it 7 1/5, which is the same thing, or you're welcome to write 7.2. All of these answers are sufficient. Okay, so there we go, not too bad. So we're dealing with the leg and these two segments here. Alright, let's take a look at the next problem. Okay, now using the same triangle, students, let's see if we can solve for segment RS. Now, QT is 4. Got it? By the way, there should be a right angle here. QT is 4. QS, the whole hypotenuse, is 12. So from here all the way across, the entire hypotenuse is 12. Find the length of RS. Now hold it, we got a problem here. Remember, this know the length of TS. Now look, listen carefully, students. Go back a page here. Notice how this leg here was adjacent to this side here. They have to be touching, okay? And I've got a problem. I don't have that over here. Now, if I was solving for QR, that would be pretty simple because QR is connecting to this segment here. So, but I'm not. I'm solving for RS. Well, some of you know what to do already. It's not that big of a problem. If the whole hypotenuse is 12 and this much is 4, then TS has to have a length of what? 8. There we go. So this leg here is the geometric mean of this segment here and the whole hypotenuse, which is 12. So that's pretty easy. Remember how to find the geometric mean. There's two ways to do it. You can take the square root of 8 times 12. That's one way to do it. So the square root of 96. Or the other way to do it is to use your ratios. So you're finding the geometric mean of 8 and 12. So 8 goes here, 12 goes here. And then your geometric mean is x. So x times x is x squared. 8 times 12 is 96. Take the square root of both sides. X equals the square root of 96. Either way, you get the same answer. Okay? So guys, that's it. You're welcome to leave your answer like this, or you can type it into your calculator and get a decimal, and the square root of 96 would be 9.797. Just put 9.8. Or some of you might like to break down 96. Let's see, 4 goes into it 24 times. So you could break down, actually 16 goes into 96 6 times, I believe. So you could break down 96 into this, cross off the 16, the square root of 16 is 4, and you could also put this for your answer. So you could put square root of 96, or 4 square root of 6, or 9.8. Any of those are acceptable, okay? I hope this video has been a help to you. I know it's been challenging. Please read over these notes, become very familiar with these theorems, and if you have any questions, don't hesitate to contact me.